Hi dear friends, this is Najeem M Illyas. Through this video series, I am trying to introduce Internet of Things, the devices and the technology involved and the solution approach. So here I am trying to put it together, that is the core device like Arduino or Raspberry Pi or any other related devices and peripheral devices and modules so that it can put together to make things work. And also I am putting together the technologies that can bring this and manage through remote platforms like cloud platforms, etc. So how the internet and the things work together, so that is whole game plan. So please keep watch on this series of tutorials, and also please comment this video so that I can answer your questions. Same time you can share with your friend circle, that way it can be spread to the whole world. Also please subscribe to the channel and also please press the bell icon so that you will get a notification for the new releases of videos. So I am trying to put maximum efforts to give simplified view of the things, how to exactly go and implement the IoT. So I will be providing solutions for various situations, that is not simply limited to the hardware part, but I will extend this to the software part so that web applications and mobile applications can also be made and applications can be used for managing the devices remotely. That is the whole game plan. So here actually as part of the IoT session, I am introducing some devices to attach with your Arduino device. This one is actually an RFID device. This RFID device actually working with the principle of radio frequency, and it has actually a kind of a associated device that can be in the vicinity of the device, and these two devices actually will be communicating via radio frequency. Okay, and this this one in the right hand side is actually RFID device, and the board is actually shown there. This is RFID with the RC522. RC522 is actually the RFID chip, IC chip. Okay, IC chip means integrated circuit chip. Okay, and that is actually embedded into that particular board, RFID board. Okay, so you have to purchase that component from the shop, and then you have to connect it with your Arduino device. So once you connect this device as per the manual, you can associate that RFID device with your Arduino device. And you have one more device will be associating with this RFID device, is actually the some client unit we can say, and that can be detected. Okay, so there is actually a Wi-Fi kind of symbol is showing there in the RFID device. You can see that that is actually sending out this radio frequency signal. Okay, and the frequency of the signal I'll actually show you the device, more details on the device. Okay, here if you come to this, actually I'm just checking all these devices online in a website called qqtrading.com.my. It's a Malaysia website. Actually I have gone to their office and I have purchased a lot of components today, and this device also I have purchased. I cannot show you directly from my table because I am sharing my screen right now. Okay, so during the sharing of the session I cannot show my camera. Okay, cannot do both at the same time. Facebook has no facility. Okay, so probably next time I will do a cam device there, one application to be installed in our computer, and after that inside that application we can connect our mobile also. So through computer, I mean through computer, mobile will be connected, and inside the app multiple devices can be clubbed together, like mobile camera I can speak directly, and the other one will be showing the shared screen.
I will do that in next time while I am doing my session, okay, through the application. Today I was not set up that. Okay, so please understand this is the device showing in the right hand side. It's more magnified. You can see that this is the main device. This device will be having an IC associated with that you can see at the center of that. That IC is actually like 522, RC522. Okay, that's RFID chip and other circuit is there. Okay, so this will be associated with it. This will be attached to the Arduino main or main thing. Okay, and here this is actually a keychain kind of a device. This can be with anybody, and the device will be receiving your radio frequency signals, and it will be sending back to the RFID device. And the RFID device is associated with the Arduino board, and this Arduino means processor. Arduino will do the rest of the things for you. So you have to do some program. The programming is actually very much easy. The logic of program is simple because that is based on your requirement. If you know your requirement is pretty well, then you can easily code that requirement. Based on these conditions, you just send this information to somewhere or do some processing. If you want to do some predictions or if you want to do some operations, all that you can perform, okay, through your code. Once you do the code, manipulate your things and then send back or send to some outside, send to inside, to the device back, whatever you can do, okay, all that options are there. Okay, this is how the RFID devices are normally working. It is working with the radio frequency. I was about to tell you what is that radio frequency and things. Okay, here the radio frequency, the frequency is 13.56 megahertz. Okay, okay, and the series of IC chips using inside this card is card are RC522, RC500, RC530 kind of. Okay, all these are series of ICs only. Okay, more or less similar functionality. Okay. Okay, I think that I made much clear, and the data transmission rate is actually 424 kilobits per second. Okay, 424 kilobits per second, you can send the data back and forth from the device. Okay, I think this is pretty much on this. I'm not going for much detail because I'm not doing an electronic section here. I'm doing an IoT section having the solution understanding. Okay, so please understand, I am giving you the solution. I'm not giving you the electronics understanding. Okay, so these devices can be used. These devices can be associated with the Arduino. How we are going to connect this and how we are actually going to get the information back to this. Today I'm only introducing the devices, not even how to program this. Okay, that part will come later on. How to exactly we can program these devices and how we can access the RFID related information, how to transmit, all those things will be coming later on. So please understand, this is only introducing the component. Here, what is the component name? The component name is actually RFID device. Okay, RFID, MyFair RC522 card reader and writer module. Card reader and writer module. Okay, then it has a keychain tag. See, you can see the keychain tag is there. Okay. Okay, how it is working in real time we will see later in a workshop. Okay, so here in a very blur image you can see how the jumper wires are connected to this. In the left hand side below you can see this is the Arduino main device, and in the right hand side on the top of the breadboard you can see right side this device is here. This is the board that we are talking about. Okay, and how the wires are actually connected. This is just simply connected. So you don't need to worry about it because like you can see the manual and see like how which pins and ports are actually connecting, which pins are connecting to which pin kind of like. Okay, and the key is actually here. Okay, so all these are here. Okay, and I think that is pretty much on this. I'm not going much deeper on this now. Okay, let's go back and we can see other devices. Okay, this is RFID device. These RFID devices can be used for identification purpose. Suppose you have actually given one RFID device to a person and the person is in the vicinity and you are sending a message to that device to check whether that device is on, then it will be getting the ID of that device. Okay, so based on that, if the person is present and he has that device with him, then we can just detect that person like that, or any information associated with that also. Okay, it's a kind of a detection only. Mostly we can use this for school students. We can use this for pets. Pets will not go very far, so pets will be around our house only. So that is the way we can just use these RFID devices. Okay, we can use this for our cattle also, our house animals also. Okay, so all these are the kind of a use that we can use, but many other usages also there. You can do a research on that. Okay, I'm going back to other devices also. Okay, let's go back. Again, I'm telling I'm using this qqtrading.com website where actually I have purchased items, so I can pretty much give information on that. Okay, now let me see. Excuse me. Now let me see which other device I can actually show you. So I'm just taking you to some other devices. Let me see. Motor encoder, speed counter, interrupt counter, light intensity module, IR infrared to 30 centimeter obstacle detection sensor module. I think we can just use this one. Okay. I hope you can see this. Okay. This module is actually, you can see the name of this thing here, IR infrared to 30 centimeter obstacle detection sensor module FC51. While you are purchasing, if you are just asking module FC51 to the supplier, they will simply find this for you and give you. Okay, IR means infrared obstacle detection. What is the purpose of this? Suppose you are switched on this device after connecting, you are switching on this device and it is working. At that time, within 30 centimeter, if any obstacle actually came, suppose a person is just passed, immediately this detector will understand, okay, somebody moved. So it will actually a motion detector. It will be acting as a motion detector. It has actually infrared rays coming from this. That infrared rays will hit with some obstacle, means it will immediately detect that something is hit. So at the time, immediately it will be sending the information back to the associated Arduino device. Arduino is always there. I don't need to tell you. These actually connectors there, these three connectors there, you have to use the jumper wire. That in previous sessions, I was telling how to use the jumper wire. So you have to actually use the jumper wire and connect from here to that Arduino main device. You need to know which pin to pin you have to connect. For that, you have to refer the manual. So every device manual will be there. So this device, this is actually a device module. Okay, it's a module, and you have to find which connectors to be connected. Okay, there is nothing rocket science. You can just simply understand what are the pins available in this, and each pin how it is working, and you have to just connect this corresponding pin to the Arduino device. See, these pins are nothing but just simply connecting between two devices. Okay, you need to know what to be connected with what. You cannot do any wrong connection. It will immediately short the device and the device will damage. Okay, so obviously you have to learn those things. That is very much fundamental thing. Okay. Okay, and I think this is pretty much clear on that. I'm not taking much time. I'm going back to the other devices. Okay, so today I'm introducing some main devices. Mostly we are using for IoT. Okay, these are all small devices only. Why we are using this? There are different purposes. Okay, this is actually like intrusion detection kind of things that we can use. Suppose you are actually putting this across your door or some place in your house, and you are not expecting a person to pass that area, and due to any reason somebody is passing that area, immediately the sensor will detect. And if you have a buzzer associated with that circuit anywhere in the device, then immediately the buzzer will alarm. Or if you have a relay and that relay will be connecting to your some other devices or your phone, even something, then immediately it will ring your phone or it will send SMS to you. A lot of things can be done accordingly. Okay, many things can be done. Actually, Arduino has SMS module, SIM card, SMS module, everything is there. If you want to send an SMS, if you want to make a call from your device, a lot of things can be done from Arduino. But this particular device is only for IR detection, the one I was telling. Okay, so based on your values detected, you can do any kind of processing based on the other modules available with your system. Arduino base processing system may have limitations, but you have to add additional modules. Okay, so previously I was telling about RFID module. Now I am telling about the infrared IR detection module. Okay, so let's go ahead with the other modules. Okay, soil moisture sensor. I'm not going for every detection. See, soil moisture sensor. Soil moisture means the water content of the soil. Okay, if you have some sensor kind of device attached to a board here, and if you put that device sensor into the ground, and it will detect the moisture of the soil, and it will send it to the board. That board will be sending to the Arduino device because it's directly connected with the jumper. In our examples we are using jumper wires and all, but in the real-time implementation it all you have to create circuits. All that you have to do with the help of an electronics engineer. They will design the board for you as per your requirement, and you have to make this, and they will install it for you. Okay, so here you have to just get an understanding of the thing. You don't need to do rocket sciences, simply understand. Okay, just simply understand, nothing. And other thing is like proximity induction sensor, NVN normality, open switch. I'm not going for much detail on that. Okay, proximity induction sensor, I'm not looking. PIR motion sensor. Okay, motion sensor, we know, like motion sensor means if anything is moving, it will detect. If anything is static, it will not detect. Okay, so simply motion sensor. Another one is motor encoder RPM speed counter. This normally can be associated with or attached to any motor, any kind of motor. Okay, and it will be capturing the motor rotation. So what is the speed of rotation? Okay, that is motor encoder RPM. I will just open it. Okay, this is the kind of device, and this device these pins are actually using for connecting to your Arduino device. But this area you have to see like how you can connect this with actually I think all these pins are not for the Arduino. Probably some pins are actually for connecting to Arduino. Some pins may be connecting to the motor. You have to see like where the electronics connections are actually coming. I'm not going to explain all that now, to introduce only. Okay, so this is motor encoder RPM speed counter interrupter sensor. Okay, the speed can be detected based on this. Okay, using this. Again, going back, many things are there, so we cannot take much time for each. So I'm just increasing my speed also. Light intensity sensor. Okay, light intensity sensor is nothing but it will detect the sensitivity of the light. It can be high or low or something like that. Okay, so this sensor will sense that. After that, this will be sending this to Arduino main device. Main device will capture that data, whatever it is sending. That data can be used for sending to your web server, mobile, anything. Okay, all that possibilities are there. Okay, so this is actually light intensity sensor. This is another module. Okay, now I'm going to see, I can show you the price also here. It's RM means this is actually Malaysian ringgit. RM is Malaysian ringgit. Okay, ringgit. One ringgit is actually approximately 17 rupees. Okay, Indian rupees. And 12 ringgit means 12 into 17. Okay, that much is the cost of this. Okay, each module is like that. Probably in India the cost of these kind of devices are much lesser than this. You can check with any electronic shop. Okay, we can just check this number BH1750FVI. Okay, and mostly the device names are actually having the main chip associated with that, and wherever the naming convention is coming with the number means there is an IC associated with that. Okay, you have to always think that way. If it is not a custom thing or it is a generic thing, obviously two different manufacturers are manufacturing this device also, they will put the IC number accordingly. Some cases the IC numbers are also can be changed, and there are certain standards for IC numbers. We cannot every time change that number. So one manufacturer is making an IC with the same functionality, means they have to follow the naming convention. Okay, kind of there, so that you will get experienced once you go more into the electronic stuff. Okay, so I'm going back to other devices. Okay, DC step down, that we don't require anyway. IR infrared, that we already discussed. 3-axis magnetic field sensor. Magnetic field sensor, if you want to sense a magnetic field presence, you can use this sensor. Okay, nothing important in our common scenarios, I'm not going for that. Electrocardiogram sensor, very good one. I think heart rate monitor. Okay, I cannot explain this much detail. I can just simply say this is the use. Okay, electrocardiogram sensor. I think mostly you guys know what is electrocardiogram. Electrocardiogram, electroencephalogram, electromyogram, lot of things are there. Okay, so this is electrocardiogram. Cardio means heart. Okay, so this is related to the heart. You can just measure the things related to heart, maybe heartbeat, I think. Okay, okay, electrical and muscular functions of heart. This device used to assess the electrical and muscular functions of heart. Okay, so I don't know how to use it. I'm very open on this. You can see from the picture there are a lot of leads there. These leads probably will be attaching to the human body, some round things. I think some time back, I have undergone some kind of electromyogram test. Okay, at that time what happened is like they just fixed these kind of round things in my body, like in the side of the heart and opposite side of heart, something in the leg, kind of like. Okay, they just put the wirings on top of our body. Okay, they will like apply some glue also, and then after that they will fix all these things and the wires, and then they will connect this to a device. As soon as they finish this, they start the machine on in their some display there. They will actually see the heartbeat. It's not normally like a stethoscope and all that we are using this using to find the heartbeat. It will actually plot the rhythm of heartbeat. Okay, it will draw. It will go up in films and all them, some olden films. Nowadays it is not showing, but in the olden films and all, we are seeing a person is in intensive care unit. The heartbeat is showing in the picture. So these kind of things are actually coming in there. Okay, so these device will be collecting those information, sequential information, and then connect, sending to uh, sending to the main Arduino devices. Okay, so these connectors are there. You can clearly see that what are the different input output options here. Okay, where power to be connected, where ground to be connected, where low, minus, negative, positive, then SDN, kind of like. You have to see the manual of this again. Okay, and see your connectivities. Okay, once you do all these and then connect this with the Arduino device with whatever wiring or number you are using, that you can use. After that, the other leads and other things also should be connected with this. This is just a simple picture. Okay, I'm saying I'm not able to explain you how to connect it. Okay, you have to get more detailed understanding on this to make this work. Okay, the top of the thing you can see like a lot of things there, like probably like resistors, capacitors, and some other devices. All that are, you can see on the top of this. Okay, so all that are there. This is actually a ready to go module, and this module can be connected to Arduino device. Arduino device is the main processor. Okay, that is your computer, we can say. That is your computer, and these are all modules for other purpose. What is the purpose of this module? This is just for uh, uh, collecting or sensing the heart and the muscular heartbeat and a heartbeat. See, you can see that here, like electrical and muscular functions of heart. Electrical and muscular functions of heart. Okay, so that will be plotting and showing for your reference. It's a medical application. Okay, so this device is good for medical. This is one medical application of this Arduino, we can say. Again, going to other devices. Okay, I think nobody's boring. If anybody is boring, please type in, say like it's boring. Okay, I'll go fast. Yeah, I think GPS module is a good module. Okay, this is a GPS module. GPS module Neo 6MW slash PPS, pulse per second, signal and ceramic antenna. Okay, this antenna is actually for capturing the signal. What signal? Geographic information that is collecting. Okay, what is that? Lat long information. Okay, longitude and latitude information will be collected. Okay, using this GPS device. Global position system, GPS. Somebody asked in private message, what is GPS? Private message. Okay, global position system. How it works? It simply works with the satellite. Okay, it simply works with the satellite, and every point on the earth actually marked with some values, and that value has longitude value and latitude value. Okay, if you want to know more about this, I will give another session only for GPS. Otherwise it is simple, understand, just like plotting a graph for xy in the normal plain paper. With xy coordinate, we just put a dot somewhere, it has an x value and y value. Okay, similarly on the surface of the earth, we have actually latitude and longitude for every point on the earth. Every point, that is very much important. Okay, so that is collected by this device. This device should be associated with the Arduino device. Then you can just transfer the location information. Okay, that is GPS module. Now I am going back. Okay, this is the module. Okay, I'm just going back. Okay, people only using private message for sending messages. Okay, that is fine. Okay, how do you know electronics? Somebody is asking. Yeah, I know some electronics, some basis of electronics. Okay, not much. Okay, that's we will discuss that later. Okay, let's continue with this. NDC thermistor 10K temperature sensor probe. Okay, this is very much important, or for demo purpose or learning purpose, we can use this. It's a temperature sensor. Okay, NDC thermistor 10K temperature. Okay, temperature sensor probe. Okay, it is waterproof. That means you have to connect this with the Arduino device, and then you have to actually put this device into some hot, for example, hot water, hot liquid, anything. Okay, and its temperature sensitivity is very high, so you can put it into very high temperature also, and you can sense it like 200 Celsius, 500 degrees Celsius, like that you can sense it. It is not just like 100 degree or anything. Okay, this device simply will be sensing the temperature. Okay, this is the temperature sensor. This can also be associated with the Arduino device while you want to sense the temperature. The Arduino device has a very high connectivity options. Okay, you can connect any good modules to Arduino. That is the beauty of Arduino. Okay, IoT device. Now, some LCD modules there that you can connect with this device, so that whatever information we are actually processing, we can actually see those information also. Okay, that is, you can send it to the screen. There are a lot of instructions there in the device. If you want to write to the screen, just write to the screen. You have to send instructions to that. Okay. So radio frequency wireless receiver also here. Radio frequency wireless receiver. That is a separate device. Anyway, I'm not going to explain it. AC voltage sensor. I think we can discuss this. AC voltage sensor. What is this? That is ZMPT101B single phase. You obviously see there is a relay. This was a relay associated with that. This the blue block is obviously a relay. Why we want a relay? Obviously, a relay is required for connecting between AC device to your DC device, and it is not simply a AC-DC converter, but this is actually a relay between high voltage device to a low voltage device, and it is a electronics to electrical converter. Okay, so that is what is called a relay. Okay, so this is that my definition may be not exact one. The purpose of this is to connect a high voltage device in the AC to a normal electronic circuit. So this relay is associated with that. So the purpose of this whole module is to sense the voltage of the high voltage line. For example, home electricity line. A single phase can be connected to this relay part. Okay, the other part of this. Okay, this is the backside of that board. Okay, so what is the purpose of this? It will be detecting the AC voltage of a single phase line, and it will be getting that value, and this relay will be actually connecting to that. But as soon as it is connecting, it will detect the value of the voltage, and the circuit associated with this will be taking care of the rest of the part, and this will again send that value to your Arduino device associated with. So ultimately, all these modules are actually giving values back to your Arduino device. So all these devices are actually kind of sensors, detectors, measuring devices, like that, temperature sensing, voltage sensing, all that. Okay, so I think you are understanding this pretty much. Okay, going back to other devices. Mostly we covered. Yeah, I think mostly we covered the major components. Let me check in my local, anything available here. Yeah, I can tell you without looking at the website, or I can even search for some devices in the net. Let me check other device what is available here. Thermoelectric Peltier cooler generator, cooler generator. What is this? Some cases I don't know. Don't blame me. I am not an expert in all these areas. I am just helping you out with my understanding on things. Okay, so thermoelectric SP1848 Peltier cooler or generator. Let's see how it is working. Okay, generate electrical energy. The only requirement is that each phase of the device must be exposed to different temperature, a hot side and a cold side. The greater the temperature difference, the more power generated. While all of our thermoelectric devices will generate power. Okay, it's a power generator. Thermoelectric Peltier cooler generator. That means you should have a difference in temperature in somewhere. Okay, and you are to use this device there, and since this device can detect two different temperature levels, based on the temperature difference it will generate electricity. That is what it is saying. Okay, a hot side and a cold side. The greater the temperature difference, the more power generated. Okay, while all our thermoelectric devices will generate power. This is a thermoelectric device. Okay, the temperature difference, it will generate some electricity. That is what this device is. Okay, you can have a reference of this later. Okay, and the IC number is SP1484. Okay, SP1848. And it's working with the 4.8. It's not a 3.3. It's 4.4, 4.8 volt. You have to always think while you are connecting your device to the Arduino, always think the proper voltaging facility is there or not. So normally in our home computer and all, we have two different voltage levels there. One is actually that 12 volt systems, and another one is 6 volt systems. Okay. But for this Arduino units, 3.3 I observed in many places, but here it is 4.8 volt and 660 milliampere. Okay. If the device is not getting this much voltage, sorry. This is not base voltage. This is actually the generator voltage. Okay. This will generate electricity with this much voltage and ampere. Sorry, my mistake. Okay. So it's basic information we can check there. In order to fix my mistake, I'm coming back here and say what is the specification. Okay, let's see what is the voltage. It is actually only 3.48. Okay, 3.48 ampere max is actually 9.3. Okay, sorry, my mistake. I corrected here. This voltage is 3 point something only. Okay, but it can generate this much voltage. Okay, so that is also important. The generated electricity, where it will go. If it is going back to your Arduino device, means your device may damage. Okay, you have to always think how to design your circuit. Those are all expert work. Don't worry about it. Okay, you need to understand how it is. That's the only thing. If you want to do it yourself with all the electronic circuits and all, you have to do some understanding. You have to learn a lot of electronics in that case. Okay, you don't need to do a complete BTech electronics course for this. You have to go for like basic understanding of devices, then voltage requirements, the device, how the device will behave with within circuits, the biasing of circuits or means devices. Okay, and main thing is like how your electricity is passing, what is the voltage difference to be applied, what one particular device will give output when you are giving this kind of input, and what is the combinational effort. You have to understand the electronic circuit fundamentals, like a series of resistors, how it will be affecting, as parallel resistors, how it will be going to affect, how the capacitor will work, what is the purpose of a capacitor to add in a circuit. All that, like a lot of stuff is actually coming. How to block electricity through a particular line, how to only pass. Those many things are there coming into place. Okay, so for those things you have to understand what is the basis of what are the basic things in the electronics. Okay, that you have to. Or ad hoc basis for per project basis also you can learn what are the components required. You just learn those things and do it. That also possible. After a long period of time, you will be learning a lot of stuff. Okay. Going back. Now, what else? So a lot of robotics things are all showing here. Okay. Actually, robotic things can be controlled through Arduino. Let me check. I will be randomly going to different portions in the website, and don't think like we are going to do all that or we are going to discuss all this. I'm just trying to go to the Arduino board. Okay. This is actually the Arduino main board. Okay. I already purchased this Arduino main board. I already purchased this. Okay. The cost of this board is 120 USD. Sorry, RM. Okay. And let's go a little detail. Let me check like which board I have. I cannot show you because I'm sharing my screen. Let me check. Okay, R3. R3. This is due R3. Where is R3? Let's check. R3 is here. Arduino Nano. Arduino. Yeah, R3. Okay, this is Arduino R3. Its price is only 35 ringgits, I think. Okay. I bought a lot of stuff together, so I don't know what is the price of each item. Okay, so this is the board I purchased. Okay, So it will be good for me also to go deeper, and because I'm doing some kind of experiments. So tomorrow I will be doing some experiments also. Maybe today also I'll be doing some experiments, not through this channel. I'll do it offline. Okay, but I will share my findings and things later on. Okay, so let's understand this main board. Okay, we were discussing about the components earlier, but we never discussed what is there in this main device. Okay, so let's actually have a look on this, and we can understand what are the components in this, and what are the different ports available in this, what are the different ICs actually associated with this. Let's try to understand. Okay, and most probably we are not going to understand everything from this website, but we will go directly to the Arduino website. Okay, before going, I'll just give you an introduction in the website itself. Okay, this Arduino R3 microcontroller development board. Okay. Now go to the details of this. See, some picture is showing here. You can see you always require a breadboard. Breadboard, I think mostly electronics people can only understand what is breadboard. A breadboard is nothing but an electronic circuit board. It has a lot of actually pin insertion points there, and the top line, it is horizontal. You can see horizontal dots there, and after that it's vertical top line. This area, this left hand area, what are seeing is actually the vertical dots, and after that these are all horizontal dots. Okay, so you have to be very careful on this. You have to just make your pins here, lines are parallel, here not, it's single line. Okay, I don't know whether you understand or not. Then we have to actually put our components. Suppose we are putting some components like resistor or anything, we have to just place it in here and then connect our jumpers nearly that. Okay, whatever required. You can use breadboard or you can use any other thing depending on you. But breadboards are easy because you can just plug and play easy. But we are going to understand what is this board all about, not for how to connect with other device or any implementation, but understand what is the structure of it. Okay, its main operating voltage is 5 volt. Okay, input voltage recommended is 7 to 12 volt. If you are applying 7 to 12 volt, the system will take 5 volt. Okay, okay, now you have a lot of things here like your DC current, amperage and all those things. Then it has a flash memory of 32 KB. Okay, and it has a bootloader already there. Just the bootloader is actually 0.5 KB used by the bootloader. Okay, that has a device program. Okay, and SRAM, it has RAM. SRAM is 2 KB, and EEPROM. If people having electronics understanding can only understand EEPROM and all. Okay, electrically erasable programmable read-only memory, EEPROM. Okay, electrically erasable programmable read-only memory. ROM means read-only memory. Okay, read-only means you cannot write simply because it is pre-built within your chip and it is manufacturer already put there. That is read-only memory. Okay, that memory you can read only, you cannot write. Okay, read only memory. You have some storage there in the memory, that is already something is stored there, and you can just simply read that area. Okay, you cannot write. And PROM means programmable read-only memory. EEPROM means electrically erasable programmable read-only memory. Okay, so this can be electrically erased and reprogram. Okay, that is a kind of memory, EEPROM. Then it has a clock speed of 16 megahertz. Clock speed means, see, every electronic device require a small current flow to make the application work. It's not like the base supply voltage that you are giving. Supply voltage that you are giving for functioning the device is different, and the clock is something that you have to give a trigger kind of something. That clock will be going with that. It will be a kind of like things. It will have a lot of functionality within that. It will be make and break kind of. It will be doing kind of like a pulse, like 1 0 1 0. It will be doing a lot of things Okay, if you understand the basis of electronics, you will understand what is clock. Okay, in every basic circuit, you have to actually give a clock. That clock will be rotating through the various components within the device, and then it will be at the end. It will go out at the end. Okay, till the end. Okay, that is clock. And the clock normally we will be giving, and then the circuit voltage will be giving. All the traces will be that we can trace. All that we can plot also. Okay, all that there. A 60 megahertz clock speed is there for this device. Okay, and this base package having Arduino and USB cable, all these are the company supplying, so that is not important for us. Okay, now we are coming to the detailing of this device. Okay, what are all the things there? This diagram will show that. Arduino, you know what are all the things there. Here you can see a USB, very easy to understand things. I can explain you first. USB. Okay, here this USB will be will be used for connecting to your PC devices mostly. Okay, you can directly connect from here to the PC or any devices, USB device. Okay, you can just connect here. That is a USB port. Here DC power jack, AC to DC adapter. Okay, you have to just connect to this AC to DC adapter, 7 to 12 volt adapter. Okay, this is actually the connection point. And here you have actually power output, 5 volt and 3.3 volt. See, earlier I was telling you this device may have a voltage issue. Here you can see one port is actually for 5 volt, another port is actually for 3.3 volt. Okay, like that. Here power input, a 9 volt battery you have to connect with this. Okay, and here we have some other things also here. 6 into analog again, 0 to 5 volt 10 bit ADC. Okay, ADC. Okay, so all these electronic terms, yeah, I am not going to explain. Okay, I even forgot certain things because I have learned the electronics years back. Okay, and not at all using the electronics nowadays, only IT related things mostly. Okay, not touching the electronic scenarios much. So all these are explained. Now coming back to this area, there is actually a reset button. If you press, your system, whatever programmed, will be reset. Okay, it will be reset. And LED, you have some indicator LED here. It will be blinking based on something. Okay, load pin 30. Okay, and here 14 into digital input output, 6 into PWM out 5 volt and 40M. Okay, digital input. I think these areas are actually for connecting the other module devices. Okay, we will go for the details later. Okay, these areas actually like this picture is not clear for me, but here these are the digital input output things that will be coming here. The picture I have to enlarge, or I have to just make. I'll just open my device also. Let me check my device. Yeah, that is correct. Only that is not clear here. I think you can see this. Yeah, that is the point where we have to actually connect this jumper, because those are all actually the pins are there in that area. Pins there. Okay, in that pins actually we have to put our jumper wires. Okay, all these are pins. Okay, and going back to other things, like here another LED for power on off, it will be showing power. The previous LED was for load, and that is pin 13. Okay, load in the pin 13, it will show the LED. If there is no load, LED will not blink. Here power on means also LED blink, means LED will be high. Okay, green or orange, depends. Okay, then another thing is like here is actually a bigger IC. You can see that is Atmel 80 Mega 328P. That is a major microcontroller part of this Arduino unit. So please don't forget about it. The major IC associated with the Arduino device is Atmel 80 Mega 328P. Okay, Atmel Corporation is actually the manufacturer of this particular IC. Okay, so Atmel 80 Mega 328P. That is IC actually in this particular device. Okay, and the microcontroller is 8-bit and 16 megahertz and 32 KB flash memory, 1 KB EEPROM and 2 KB SRAM. If you're not understanding this, please forget about it. Okay, no need to understand all these technical details. Even if without knowing these technical details, you can do your Arduino implementations. Okay, any layman, anybody having some enthusiasm can do this and implement. Okay, that is the beauty of these things. And if somebody having some basic understanding, even computer understanding or mobile understanding, then very basics of electronics also can understand a little more. A microcontroller device is having its own processor unit there, and it has all the functionalities built into this as a processor, but it has limitations. What are the limitations? It is only 8-bit processing. Okay, it's not even 16-bit or like that. In the very early stage of computing, it is just like 8-bit or 16-bit or like that. Now the computing capabilities are very much high. Okay, so this is simply 8-bit and 8-bit processor. Okay, and then 16 megahertz frequency, 32 KB flash memory. The flash memory is required for doing operations. Okay, that memory is required as part of this. So that flash memory, it will be temporarily storing those information. Okay, whatever that during the process. Okay, 1 KB EEPROM also there, 1 KB. That's all small thing, but just need to store certain things. Then obviously we need these kind of things. That is 1 KB EEPROM, 1 KB SRAM. Okay, that is it. I think I have explained most of the parts in this Arduino device. I am going to recap it. It's actually a USB connection endpoint. Okay, connection socket, USB plug. You can just plug your USB here. You have a AC power adapter input here, and you have a reset button for resetting your device. Okay, and you have two LEDs, one for the load in the pin 13 that will be showing this LED up. If the load is there, LED will be showing. Okay, load in the okay. And another thing is like here LED for power on of this device. This device is connected to power means immediately this LED will on. Okay, that's the first thing. You have to connect the device to the power. You have to see LED on, the device is working. If the LED is not on, something is there in the in your device. Okay, and apart from that, we have a lot of power related things here like power input, power output, and you have analog inputs. Analog inputs is like it is not a digital thing. Like you can just put like A1, A2, A3, A4, A5. You can see like A0 to A5, 6 analog units there. You can just add a 0 to 5 volt or a 10-bit ADC connection. Okay, then it's just you can just put analog power here directly. Okay. Another option, you have a 9-volt battery input you can give here, and you can get a 5-volt and 3.3 volt output. Two outputs you can get. Depending on your device you are going to connect with this, you can just get the power out of this and supply to that device. Okay, you understand? Suppose you want to supply 5 volt to another associated device. For example, that motion sensor something required 5 volt, then you have to just connect to this pin. If you are temperature sensor require only 3.3 volt means you can just connect with that accordingly. Okay, so you have to identify which thing here. You can in the device. Let me control plus plus. Control plus plus. Oh, where it is born. Yeah, it's very big now. Now you can see inside the board it is writing everything. 3.3 this one, 5 volt this one, CND this one, another CND this one, V in this one, like that. Okay, so this is how it is actually written. So it's very easy to understand. Okay, even without document, but you have to refer the document before doing any connection, before switching on your power also. Otherwise you'll just hear a sound like a tuck, it will bend. Okay, so you have to be always very careful with your power connections. And also if you are using any kind of AC devices to do some experiments, be very much careful. You cannot directly connect AC power to devices easily, because it will immediately burn, or it will give a electrical shock and a lot of things. Okay, be careful. All these things I am giving you for the learning purpose. Please don't experiment with like unnecessary experiments. There's no risk involved in this. Okay, so my disclaimer. Okay, do your things with your own risk, but be careful with your handling, and be reading the manuals, or always take some experts help while doing these things. Okay, don't try to do kind of a heavy experiments. Okay, you can do light experiments yourself. Okay, this device is actually going more detailed. Like you can just see like a lot of colored things. You can see like ground, power, control, physical pin, port, pin function, digital pin, analog related pin, then PWM pin, serial pin, IDE, sort of like that. Okay, so we are actually going to see the thing is here 7 to 12 volt depending on current drain. Okay, this is your power. Just like our Nokia mobile charger, kind of like one socket will be here. You have to just connect that power to this. That's one thing. Here, a USB jack. See that USB jack is here. USB you will be connecting to your computer. The other side will be connecting to your device. Okay. I already have a USB device here. Sorry, USB connect means like cable here. In that case, actually, just like our printer unit, how we are connecting our printer unit to computer, USB will be in the computer. The other side will be in the device. In the device, it will be completely different in shape. You can see this is the shape of that. This is not actually the USB in computer. The other side will be like this, and the computer part will be actually USB. Okay, so this is how the USB jack type B. Obviously this is type B. In the device it is type B. Okay, that is USB jack. These two things are very much important. The first one, this is for the power to connect with the device to turn on the device. Okay, and this is USB jack, that we have to just connect that USB cable to the computer in order to do any kind of operations from the computer to this device. Okay, now we are going to see more on this, like these white dots you can see. Okay, here actually a reset button is here, ground button is here. These two are, you can see, like, okay, the first one in the left, that is actually ground, and the other one is actually reset. Okay, okay, here the 5 volt, and here is MOS 12. Okay, 12. Now this red one is showing is as a reset button that we already seen. Okay, now whatever not explained previously, I can just show, otherwise nothing, because these are all very deeper. You have to understand these things in order to make your program run successfully. If you are doing a program yourself, you need to understand a lot of things. Okay, each and every pin in this device, and it has its own functionality in the sense like its own connectivity. So you need to understand which pin, what where to connect, what to connect, what not to connect. Those kind of things you have to understand. Okay, external devices, how you are connecting, power, how you are connecting, power how you are getting out of it, and analog power, how you are going to connect, other devices, how you are going to connect, how you are connecting multiple devices at the same time. All this you have to understand. Okay, here lot of things, the numbers are there here. See numbers starting from which, see this 0 1 2 3 like this. How many numbers? I will explain all this when we are doing the programming context. Okay, okay, so we have understood the very basics of Arduino microcontroller system. Okay, okay, so this can be put anywhere in a small device. You can even pack it with any device, suppose you want. Okay, you can pack it with devices and club together with the modules. Then you make your electronic boards accordingly, connect with each other, and then make your systems working. Okay, cool. Suppose you have to start developing applications, you need Arduino software. Okay, so now let's see, it's coming. Yeah, it's coming now. Oh, perfect. Okay, this is the tool where we can actually write Arduino code. Once you are doing all these activities in the hardware level, connecting those sensors, detectors, everything as proper with the proper power systems, everything. connect everything ready. Then you have to do some kind of coding and pushing that code to your device in order to make the processing functioning, everything. You have to write code, right? So that code you can write in this kind of device. I'm just going to control plus plus again, control plus plus. Why am control plus plus? Because how this IDE looking like. This picture I am just showing. Okay. Oh, it's set up blah 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 blah, something like that. Okay. Or they are saying you can do code online. Now it is loading a very simple diagram. Okay. Okay. It's pretty easy to understand, I think. Only for technical people, not for non-technical people. Okay. And non-technical people, don't worry. This is nothing. Okay. Here, what you see, you have two parts. On here, one IC you can see here. Okay. That IC number is showing here. Okay, this is the IC number, the below, not the selected one, the below of this box. That is IC number showing here. Another one is here. Okay, this one under this, the below of the box, another IC number is showing here. Okay, these two ICs are actually there. Okay, and both are HTML something. I have to plus plus, then only I can see this. I think control plus plus. Okay. While I do things, I will not go much deeper. I'll just simply do as is. I'll do my first working things, then I'll go for the details later. That is my way of doing things. I have to see something working, then I'll go for analysis. Okay. Here it is ATMEGA16U2. Here ATMEGA328. This is the main chip. Okay. ATMEGA328. We have already seen 328. Okay, this is our main Arduino board. Okay, this is our, sorry, Arduino processor. Okay, IC. And ATMEGA16U2. What is this U2? Reference design are provided as is and with all faults. Arduino disclaims all. Okay, this is actually a reference design. Okay, for your implementation purpose. Lot of things you can see here. I believe I forgot anyway. This is operational amplifier. Here an operational amplifier. Here another operational amplifier. Here some blah 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 circuits. Okay, don't worry about it. Forget about it. Okay, let's close this and go back. So I don't give you any panic. If you panic, you cannot do anything. So be cool. So guys, I'm just coming back to Arduino. You know, in the Arduino.cc. Arduino.cc is actually the original manufacturer website. Okay, this is the original manufacturer website. Previously, I was showing this from a seller website. Now this is the Arduino manufacturer website. Why I came to this website? Because we need to know like what software they are. We need to know other component details and its specifications clearly. Okay, so I'm coming here. I need more information on this. So I'm just going down. Okay. So they are saying, is the best board to get started with electronics and coding. Okay. So that is the reason I purchased this. Okay. There's some pictures here. You can see. See, this is very small. That is what it is showing. See. Okay, come back and see like here the overview. You can just mention. You can just understand which website it is. I just copy this to your chat screen. Okay, in your comment screen. Okay, I just put it here. This whenever you are getting time, you click on that. Don't do now. If you are doing right now, then you cannot concentrate on what I am telling. Okay. Arduino Uno is a microcontroller based on which microcontroller? 80 mega 328p. Don't forget about it. Okay. This you don't forget. 80 mega 328p. Okay. As per the data sheet. Okay. It has 14 digital inputs and output pins. Total 14 pins there. Okay. 14 pins there. 6 can be used as PWM outputs, 6 analog inputs that we have already seen, 16 megahertz quartz crystal is there, and a USB connection is there, a power jack is there. Okay, an ICP header and a reset button also there. Okay, I'm not giving explanations on this. You can easily connect. See, another thing is like you can easily connect this to a computer using the USB. Okay, USB cable or a power with AC to DC adapter or battery to get started. One USB cable you have to connect it with the computer, and one AC adapter that you have to connect with the power. Okay. Don't worry about much details about the device. You just start your thing, connect your things, do your blah blah coding, and just put whatever sensor something into your board, just jumper wires and all. No need to do any electronics things. Just do basic connections using jumper. Okay, you can do it. After I give these sessions to all of you, you can try yourself. Nothing to worry. Simple. Buy some components. Go to the shop. Buy some components associated with this. Just get your breadboard, get your jumper wires and these devices. Just simply look at the pins where to connect. Just simply put the pins connected, nothing to solder. Simply connect. After connecting everything proper, ensure everything is properly connected with the power things and all. Then you switch on the device. Okay, switch on your power. Then everything working means your board will be having the LED lighting and your power according to your things. Other LED also will be load LED will be also be blinking. And then depending on what input output you are planning, just write a couple of codes in your thing. How to set up the code environment, how to connect it with the PC and push the code after pushing the code to your device, how this will be working. Once you set all the program, everything inside your program, inside your chip, inside your microcontroller, you can disconnect from the PC. PC is not required for this. Okay, PC is just a device to connect with and see monitoring, and also you can do coding, pushing, everything. Okay, after everything you're done means you can just leave the PC away from this, disconnect the PC, put your things somewhere, and then you can just connect this with the internet through Wi-Fi or Ethernet cable, whatever possible way you can do that. You have to add some Wi-Fi module to that. I already purchased the Wi-Fi module today. Okay, that Wi-Fi module also you have to using jumper wires and all, you have to connect with the device. Okay, that way we can do it. So once you connect with your Wi-Fi, then your device is already connected to internet. Now your device can be detected, or your device can send a request to your Google or any kind of like provider website, and then you can send information using certain techniques, and you can just get the information back from the device, and then kind of like it's just like a browser kind of stuff that you can send and receive your things, HTTP requests. Okay, it's not a browser, but acting like a client agent kind of. You'll be sending your HTTP things. Okay, we will discuss all that later, not today. I was thought of like giving some session related to the web application development, how we are connecting to the web application through this modules, and connecting to internet, and then connecting to your web application, getting your data processing there. But unfortunately, due to many reasons, the time also not proper, because I purchased all these components today. That is the reason I have actually introduced the components in detail. Okay, so ultimately we cannot do the programming today. So we will be having another session. We'll have more detail on the device pins and other things, device instruction points. After that, we will be setting up a software for editing this thing. After that, we will be start coding. Okay, basic coding. Okay, all that's very easy to do things only. Okay, don't think everything complicated. Don't make anything complicated. These are all actually really complicated things. Okay, but don't think complicated. These are all very simple. Okay, just drinking water like. Okay, go to the device, understand the device, all the pins and other things. What are the different instructions actually associated with this microcontroller, and how actually we are going to use that for programming, and how this editor software is actually helping us. Okay, so what are the different components or libraries available in the software, how we can easily do the coding, how we can compile the code, how we can push the code to the device, and ultimately how the device will be understanding the peripheral devices like modules associated with that. For example, the temperature sensor, the IR detector, RFID detector, RFID, or the in IR infra, what is that? Infrared detector, anything and everything. Okay, there are a lot of n number of devices there to connect with Arduino, but Arduino should be connected with internet to get it remotely managed. See, those things are different. If you want to connect remotely and manage, you can do that. If you don't want, you can do within the Arduino itself. Okay, lot of things can be done without internet also. Okay, for example, your home automation you can do completely with this Arduino device. You don't need bigger computer or bigger mobiles for that. Arduino is very low cost thing. That is the beauty of Arduino. Okay, people thinking like, I have a mobile, I have a computer, I have everything there at home, and I can connect everything to my home computer with some kind of adapters or some kind of device connectors. Okay, then I can do everything, right? But the cost of a computer is how much? Too high, right? Very high. But Arduino device in India, hardly 1,000 rupees, 1,200 rupees, I think, maximum 1,500 rupees, I think. Then components, each components 500, 800, 200, like that, each component. So very small components. Okay, 10 ringgit means 170 rupees only. 10 to 15, 30, 40, 50, maximum 100 ringgits, like that. Okay, so all that depending on what is the applicability and what is the complexity of the device, the price will be vary. So ultimately, implementing a home automation system with Arduino, the cost will be very less. So that is the reason like you have to use this kind of a very mini computer, that is microcontroller. Okay, microcontroller devices you have to use, and ultimately it is a cost saving thing, and it's a very easy to implement thing, and you can pack it up in a very small area. There's no much space required for this. Okay, and if you want to connect this with a PC, if you want to connect with this mobile devices, if you want to connect with say, any other interfacing devices like LED display or anything, you can do that also. Okay, all possibilities are there with this microcontroller processing unit. Okay, Arduino unit. So I think almost 1 hour, more than 1 hour I have taken now, and I think this is time to wind up this session. I hope everyone enjoyed this session, and hopefully I have given a basic understanding of the Arduino device, and I have given a basic understanding of how the peripheral devices or the modules associated with this Arduino device can be associated. Means how can we use that? What are the different type of devices available? Basic. I have only given few, but if I'm giving 2 or 3, then you can understand how the millions of or hundreds of such things are working. Similar way. Okay. All that depends on based on our requirement. We can just select which item to be used. You have to understand what specifications are there with the device, what we can actually measure from the device, which format it is coming, after that how to digitize it. All ultimately everything is digital world. Okay, convert everything to the digital world. The modules are actually working for converting those things, sensing the temperature, sensing the motion, whatever, all that finally converting to digital terms. For example, on off, 1 or 0 kind of. Okay, true or false kind of. And ultimately temperature means some value, 10, 20, 40, 100, 200, like that. So digitize it, detect it, digitize it, then pass to the device. The device can do a lot of process like conditionally doing something, sending to some device, process it, all, even switch on off kind of instructions. Okay, get the instruction, process the instruction, who sent the instruction, to whom the instruction to send, which device, whether it is RFID or a temperature sensor or any motion detector, who sent this, all this device can understand. That is the way the device memory, device stack is actually working. Okay, so it will be easy for the device will understand this. We have to do the programming accordingly. Based on that, the device will respond back to respective devices. Okay, so that is how it is. So I think I have done my session, and hopefully this session everyone enjoyed, and I will come back with another session next time, probably tomorrow or next week. And my weekends I'm going to utilize for, or give my time for you guys to start work on the Arduino or Raspberry Pi. Raspberry Pi I have worked earlier, Arduino I have recently started working on, and I am doing a lot of experiments also, so I'll help you guys to understand. So again, I'm saying I have some good electronics background. I'm not saying I'm an expert. I have good electronics background. Also, I have IT background. Okay, I have done my electronics and communication engineering. Okay, from the government engineering college at IT. Okay, the same time, not same time, same. After that, I have actually done my MTech in computer science from BITS Pilani, and so not only that, I have good experience in the IT industry. Okay, clubbing together, I can say like I have real expertise in the technology area for application development, but in the electronics and circuit design and implementation area, I'm not an expert. I'm very honestly telling you. Okay, but application development, implementation, APIs, any kind of processing, any kind of the code pushing to the device, anything and everything from the in the perspective of application development, I am an expert, I can say. All these sessions I am giving free of cost, and there is no charging for this. And later also, I will not do any kind of charging for these sessions. And a disclaimer: anything happen to the device or anything, I am not responsible. You have to be very careful in doing all these kind of things. That's my disclaimer. Okay. Thank you very much for watching this video live session. I am Najeem M Illyas signing off. Thank you. Bye.